This is going to be chapter 4.1 and 4.2, and we will talk about exponential functions. So we've been doing a lot of different types of functions. We talked about linear functions, absolute value functions, polynomial functions, quadratic functions, and rational functions most recently. So now we're going to talk about exponential functions. So this is probably going to be review for many of you, but here it is. So usually when we talk about a function, or at least an exponential function, it usually has this type of form, okay? A times bx. Now this b, well, let me write it a little bit differently. Sometimes without the a, you can write it as bx. I think this might be a little easier to kind of just see. So this b in this case is going to be what we call the base. So this guy is called the base. So this x is no longer basically the base. Now this x is going to be the exponent. So some examples of an exponential function would be like if you had f of x is equal to 2 to the x, or f of x is equal to 1/2 to the x power. So you have these types of functions, and these functions appear a lot in chemistry, for example. So if you're looking at exponential decay, here you have a decay function, here you have a growth function if you were looking at bacteria. So now this a is usually just a scaling factor, kind of just stretching the graph, and so on and so forth. So why don't we go ahead and start off by looking at what exactly these graphs kind of look like. So so usually we're going to start off with f of x is equal to 2 to the x. So we're going to look at something that looks like that. So one of the things that we can do is that we can start off by plugging in points to kind of get a good idea of what this looks like. And this graph actually is in the parent function. So if you quite don't know, you can go ahead and take a look at it. But basically what you're doing is you're plugging in some numbers. So let's start off by plugging in 0, 1, 2, 3. Okay, let's see what those values are. So I have 2 to the 0 is just going to give me 1, because remember 2 to the 0 power is always going to be giving a 1, okay? Or just in general, a to the 0 is just equal to 1. I plug in 1, so I'm going to get a 2. Plug in 2, you're going to get a 4. Plug in 3, you're going to get an 8. Okay, so here are a couple points. Now let's plug in a couple negative points. So let's plug in -1, -2, and -3. So when I do 2 to the -1, well, that's just equal to 1/2. I do 2 to the -2, that's going to equal to 1/4. 2 to the -3 is going to give me 1/8. So if I were to graph these points, so if I get 1, 2, 3, 4, 0, -1, -2, -3, so on and so forth. When it's 0, I'm going to get 1. Okay. When it's 1, I'm going to get a 2. When it's 3, wait a minute, 0, 1, 1, 2. When it's 2, I'm going to get a 4. Okay. And then when it's 3, you can see that I'm going to get an 8, 4, 5, 6, 7, 8. So you can kind of see that this guy is going really, really fast, really quickly. So it looks kind of like that. And then, let me get rid of the 2 to the 0. And then, let me plug in the -1. The -1, you're going to get 1/2. 1/2 is around there. Then when you put in -2, you're going to get -1/4. That's a little bit there. Then 1/8. So notice here that this is getting smaller and smaller and smaller, but it's never going to reach 0, which means that there's something called a horizontal asymptote in there, which is basically what we were talking about. So you have a horizontal asymptote at 0. At y equals 0. Okay? And actually, when the base here, if my base b is greater than 1, what you have is something called exponential growth. Because what happens is that this function is just going to be growing and growing and growing exponentially because you're taking 2 to some sort of power. Okay, so, and it's just getting bigger and bigger and bigger. So this is what we call exponential growth, which is going to be the opposite when we look at a function that looks like this. So if you have a function now that instead the rate is now 1/2, okay, so every single time you're halving everything. Well, now here my base, and I'm going to write here b is going to be between 0 and 1. We're not going to put negatives, okay? So, so what we're going to do is we're going to try to graph this again. So we're going to do the same thing, x and y, x and f of x. We're going to plug in 0, 1, and 2, maybe 3 also, and we're going to also plug in -1, -2, and -3. So when I do that, anything to the 0 power is going to give me 1, so that's a 1. Then you're going to get 1/2, 1/4, 1/8. Okay? When I put -1 in there, so 1/2 to the -1 power, that basically flips it to a 2. 1/2 to the -2 power is going to give me flipping it to a 4. 1/2 to the third power, -3 is going to give me an 8. So notice that this is kind of the opposite of this guy. Okay? So when I graph this, you're going to get 0, 1. So notice that this hasn't really changed. It still looks like that. Okay? Then you're going to have 1. When you plug in 1, you're going to get 1/2. When you plug in 2, you're going to get a 4th. When you plug in 3, you're going to get an 8th. So this is getting smaller and smaller and smaller on this side. And on the other direction at -1, you're going to get equal to a 2. At -2, it's going to be equal to 4. Okay. And at -3 is going to be equal to 8. 2, 3, 4, 5, 6, 7, 8. This guy's going to be all the way up to an 8. So this guy is going to look more like this. Okay, so this is still growing. It's still growing exponentially, but it's growing if you look at it from right to left. But since we look things from left to right, you can see that it's decaying. So whenever your b value or your base is between 0 and 1, you will experience something called exponential decay. Okay. So you can kind of look at these factors very easily, that the greater the factor, the more faster it's going to be. So you can think about, if I were trying to compare f of x is equal to 2 to the x with f of x is equal to 3 to the x, notice that this guy's going to be much faster. Okay, it's going to decrease at a much faster rate. Okay, so one of the good things that you might want to know is what exactly is the domain and the range. So if you look at this guy, the domain for exponential growth, notice that it's all real numbers. Okay, because you can put in any number that you want in here and you're always going to get a value back. The range, however, is going to be basically where the horizontal asymptote starts, which is going to be from 0, not included, all the way to infinity. And usually when we think about the range, we're always thinking about where is the horizontal asymptote. So wherever the horizontal asymptote is, that's going to be the first, that value right there. Okay. Now if we look at exponential decay, and if we think about domain and range here, the domain is also going to be all real numbers, -infinity to +infinity, and the range is going to be from 0, not included, all the way to infinity. Okay. Some of the things that you can see here is about the exponential functions. So some key things, some key features. Exponential functions have a y-intercept at 0, 1. So regardless if it was exponential growth or decay, it always is 0, 1. Domain and range are the same. regardless if you have exponential growth or decay. If your base is greater than 1, you experience growth. And if your b is between a number from 0 to 1, you experience decay. So think about it as a fraction that's between 0 and 1. You're going to experience this exponential decay. All right, so one of the things that we can do, so let's start off first, before we get into the graphing, let's start off by finding an equation of for an exponential function. So finding an exponential equation. Okay, so for y equals abx. Okay, so typically, just how we had y equals mx plus b, this is going to be kind of like the exponential function for the y equals mx plus b for exponential equations. So let's just do an example. So find an exponential equation that passes through the points. So let's do first 1, 3, and then 2, 4.5. So we'll do that one first, and then we will do negative 2, 6, and then 2, 1. And for this one, we want to round to 4 decimals. Okay. So we want to first find an exponential equation that passes through these points. Okay. So the first thing to kind of notice is that these are two different x values, xy and xy. So why don't we plug in both of them? So I'm going to plug in, so we know that our equation should look like y equals ab. So here we want to figure out what is a and what is b. So let's start off by plugging in the first point. So that's going to be 3 is equal to ab to the power of 1. And then the other one is going to be 4.5 is equal to ab to the power of 2. Okay. Alrighty. So now what we can do here is that we can try to solve for the value of one of them. So I'm going to notice that this guy can be 3 equals ab. I'm going to solve for 1. So I'm going to divide by this b. I'm going to get 3 over b is equal to a. Okay, and then what you can do is you can plug that back into this guy. So you have 4.5 is equal to a, which in this case is 3 over b. Okay, and then you have a b squared there. So I'm going to have 4.5. Notice here, 1b is going to cancel out, so I'm left with only 1b there, so it's 3b. And when I divide by this 3, you're going to see that b is going to be equal to 4.5 divided by 3. It's going to give me 1.5. So that means our b is going to be 1.5. Now we just need to figure out what a is. So I'm going to plug it back into the original. This 3 equals ab, which is this guy. So now a, I don't know what it is, and this is 1.5. And divide by 1.5. So a is going to be equal to whatever 3 divided by 1.5 is, which in this case is 2. Okay, so now that I know what a and b is, let me just plug it back into the original. So you're going to have y is equal to 2 times 1.5 to the power of x. Okay, now one thing that is a common mistake, do not multiply these two out. Don't do it. Remember, the exponents go first. So this would be your final answer. Okay. Alrighty. Now let's look at this last problem. Okay. So again, we're going to do exactly the same thing. xy, xy. So we know that y is equal to abx. So we're going to plug in the first one, which is going to be 6 is equal to a, b, and then the next one is negative 2. And then the other one's going to be 1 is equal to a b squared. All right. So remember that a negative, when you have a negative, you can always bring it to the bottom. So you have a over b squared. I'm going to multiply by b squared to both sides, so you're going to have 6b squared equals a. And now you can plug it into the other one. So you're going to have 1 is equal to a, which is 6b squared times b squared. So you have two of them in there. Okay, so this is going to give me 1 is equal to 6b to the 4th power. Okay. Alrighty. And now what you're going to do, you're going to solve for this b. So I'm going to divide by 6. So you got b to the 4th equals 1/6. You're going to go ahead and take the 4th root of this guy. Okay, so b is going to be equal to... Now notice that when you have the 4th root of this guy, we typically add a plus or minus, but b can only be positive. Okay, so you're only going to take the positive of it. So what you're going to do is you're going to take the 4th root. 4th root, I'm trying to write it here, of 1/6. And what you're going to get approximately to 4 decimal places is 0.6389. Okay, so that's the b value. Now we're going to try to figure out the a value. So we're going to plug it back into, I don't know, it doesn't really matter. Let me plug it back in here. So 1 is equal to a times 0.6389 squared. So you're going to get 1 is equal to a. Let's square that number. So 0.6389 squaring it is going to give me 0.4082. And then I'm going to divide that number out. So I'm going to get rid of that. So a is going to be approximately equal to 1 divided by 0.4082. That's going to give me 2.4498. Okay, so now that I know what my a and my b value is, I can just plug it back into the equation. So y is going to be equal to 2.4498 times 0.6389 to the power of x. So that is going to be the exponential equation. So you can kind of see that the first guy was growth, because you can see that the b value is a positive number, or a greater than 1. And for this one, it's exponential decay, because you have a number that's between 0 and 1. So in the next video, we will do some graphs and we'll talk about compound interest.